Now, there's one, we're going to do one more example for example number 1, and this is important, so I want to write this down. For this one, this is kind of, it's critical, but it's not really critical, but it'll mess you up if you don't do it the proper way. What do you notice that's a little different about this expression compared to the other expressions?
Negative a. It's negative x squared.
Yeah, it's a negative a, so what I need to do is factor out a negative 1. So I'm going to say negative 1 times x squared minus 13x plus 12. And so when I factor out the negative 1, I'm just going to change the signs of each term, right? Does that make sense? Then I leave this negative 1 out front here, and then I'm going to fill this in like this. Now, I'm going to factor using these terms. So I'm going to say x squared and positive 12. Again, I need two numbers that when I add them up, they equal positive 12. Notice that my middle term is negative. So that means I'm going to have a negative term and a negative term, right? So I've got x and x. Then two numbers, when I multiply them together, I get positive 12.
12 and 1.
Or I mean, when I multiply them together, I get positive 12. But when I add them together, I get negative 13. And somebody blurted it out. They said negative 12 and negative 1 would work, right? So I get negative 12x and negative 1x. If you add these two together, I get negative 13. But when you multiply them out, I get a positive 12.
Yeah.
So I would say x minus 1, x minus 12. And this whole thing is the factor. Don't forget this little negative 1 because it makes a difference. Okay? So we always want our a term to equal 1. Well, not always. We could do it if it has another number, but it's easier if it's positive. Otherwise, it gets complicated. Okay? Yes?
So that negative 1 that's outside of the parentheses is still going to be multiplying the x minus 12 also?
Yeah, you could still go through. What happens normally is when as we progress in our textbook, this is usually set equal to 0. So when we factor out a number, if we divide both sides by negative 1, right? What's 0 divided by negative 1?
0.
0. So you end up with x minus 1 times x minus 12 equals 0, and then you go through and you solve the equation setting both factors equal to 0, blah, 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 blah. If there's an x, though, in other words, if I factor out, like, let's say over here I had 2x, well, then it gets a little trickier.
When you have to do every term in the original equation and factor out a 2.
Yeah, you got to be able to factor out of each term. So you're going to find the lowest common, or the greatest common factor of each term and pull it out if you can. So the greatest common factor of all these is negative 1. It's not even a common factor because it's 1, but we're just pulling the negative out. Okay? So now let's move on to example number 2. And so example number 2.
You guys or something.
Look at this. I've got 6n squared plus 9n. Now I want to show you guys something cool. The greatest common factor, there's this long, complicated way to do it. If I have 2 times 3, right, of 6, and this is called prime factorization, basically what I do is I take a term and I find all the factors until I have prime numbers. And then what I do is I look to see what is the greatest common factor. In this particular case, this has a 3 and this has a 3. Now sometimes you'll have other numbers. So if they both had 5s, then you would, the 5s. If they both had 2 sets of 5s, then both would have 5 squared or whatever. But we try to match up everything they have in common, and whatever I could circle, whichever factor I could circle from both of those, that's the greatest common factor. I would multiply it out. But in this case, it's just 3. And then the other thing you would do is the same thing. What's n? Squared. Well, that's just n times n, and then we have n to the first power. Well, that's just n times 1. What do they have in common? N. Okay. So now what I can pull out is 3n times something. Then I got to think to myself, what times 3 gives me 6?
2.
What times n gives me n squared? N plus
3.
What times 3 gives me 9?
3.
And then what about the n? N
Stays the same.
Yeah, I just leave it alone, right? Oh, no, can't write it that way.
Because it's outside.
It wouldn't be there, right? Now, you might be tempted to do that. Let's assume you do that. What happens when I multiply 3n times 3n?
9n squared.
Yeah.
Which is
So I can't have the n there. I gotta get rid of the n, okay? Does that make sense? Okay, so now that's it. That's how I factor out that expression. So that one, we don't need a long, fancy formula. We just kind of need to figure out the graphing thing, right? All right, so now let's do one more. Shh. Let me do one more example for example number 2. So example 2b, we're given the expression 4x squared, 20x plus 20x, minus 56. Now this one we're going to do a bunch of stuff. First of all, if I look at this, if I were to do that prime factorization thing, you would see that 4 goes into all of these numbers. So I'm going to factor out the 4 first because it makes my life a little easier. So this would be x squared plus 5x minus, what do we multiply 4 by to get 56?
14.
Are we sure? Yep. 16 and 40, yep. You're right. 14. Okay, now what happens is, you always double check. When you factor something out, multiply it back in and make sure you get the line above, right? So I would think in my head, this is what you want to think. You don't necessarily have to write it out, but just think it through. 4 times x squared, 4x squared. 4 times 5x, 20x. 4 times negative 14, negative 56. As long as that matches up, you're good. Now we're going to factor this stuff. So I'm going to draw my little grid over here. And I'm going to say x squared and minus 14. Well, this is x times x. Now remember, because this is a negative sign, one of these has to be positive, one of them has to be negative. Because I'm going to multiply a product, they have to be different signs in order for the product to be negative. But whatever those numbers are, they have to add up to equal 5. Well, 2 and 7 are multiples of 14, right? So I got to figure out which one's positive, which one's negative. 7 is the greater number, so 7 probably has to be positive because our middle term is a positive 5. So if I make this the positive one and make this the negative one, I get negative 2x plus 7x gives me positive 5x.
Yep.
And negative 2 times 7 is negative 14. So this final factorization, and we call this prime factorization, is 4 times the quantity x minus 2 times the quantity x plus 7. Does that make sense?
Yep.